Okay, so let us start. So we'll inshallah be discussing a project and the lecture together. Okay. So my first question is: have you thought anything about your project? A problem? That's fine, but at least have you started thinking about it? Have you started talking within your group? So just keep in mind, we are not looking for MM1 kind of systems, okay? We are looking for queuing networks, where first of all, we have either parallel or in series multiple queues happening. Secondly, there is a problem when even visually you go there, you see queues building up and, businesses struggling to deal with the situation, right? So we are talking about those kinds of problems. Now, what you see on the screen is like your whole blueprint for how you're going to conduct this study, okay? So what is the first thing you have to do? You start from this side, from the left side, and we'll going towards right. So problem formulation, okay? So there's something called problem formulation, which simply translates to, we'll go in each of these boxes in detail, okay? So don't worry about it. I'm just giving you right now a higher level description of these things, okay? So we'll start by describing the problem. Describing the problem could be in any form. You have been taking courses in HCI and system analysis and design, whatever. We require a statement that clearly tells that there's a problem happening. For example, I can say that we are talking about King Fahd Teaching Hospital's emergency department, and then you state that the department is facing queuing problem where patients come and they have to wait for, like, say, an hour or 2 hours, and something that describes the problem. Okay, so this is called problem formulation. And then based on the problem you're facing, you need to set up what you call your objectives as well as what you call your project plan. Okay, inshallah, we'll be focusing on these 2 points today. And then, of course, then we'll be talking about data collection and model conceptualization, in the later parts of the project. So let's just go deeper into what each of these means. So statement of the problem is needed so that the problem is clearly understood by simulation analyst, and the formulation that whatever the problem you have defined as a statement must be understood by the client as well. So here you don't have a client as such, right? You're not talking to businesses directly, you're just working on your own. But the problem statement should be in a way that it must be clearly understood. Now, this is just like an introduction to your report, right? So you don't have to worry if this is sufficient or not, because it is followed by a few more things that will make things, more clear. Okay, so keep it as a general statement, but still good enough to understand whatever is going on. Okay, so the question still remains: what should be part of it? There are a few more details. You need to determine the questions that are to be answered. Again, we'll keep on expanding, some more details, so you'll get to know about all these things better. So determine the questions that are to be answered. You remember why and what? When we did the initial part of simulation. So we are kind of pointing towards that. What are we trying to measure, and how we are trying to solve certain problems. Okay, so this is pointing towards questions. Inshallah, we'll be going into details of this inshallah later. But identify scenarios to be investigated. What does scenario mean? We'll explain it inshallah on the next slide. Okay. Then we also need something called decision criteria. Right now we are building up a list that should be part of our if not problem definition, the objective itself. So if I don't see clearly the questions that have to be answered, it means there's a problem. After your general statement, okay? After problem definition, the next section must address that these are the questions we are trying to answer. And then there must be a section saying that this is the scenario to be investigated. And then there must be somewhere where you're saying that this is the decision criteria, these are the end users, and then these are the data requirements for the study. Is that clear? So this is self-explanatory. This is like the subheadings for your report in the second section, okay? And then in the real study, I've separated, the last few points later. In the later part, you see some additional things which you actually need when you're performing this study with a company. That many a times you don't have the right hardware and the software, so you need to identify the hardware and the software requirements. Plus, you're doing project management, right? So you may require timelines and some other plannings like requirements planning and so on. So this is kind of reflecting the project management part of it. Prepare timeline, cost, billing procedures, and so on. So I should just say the last 2 points are reflecting, what you're studying in project management. Okay, so before we, I'll come to this in a second, but let me at least address the scenarios, the decision criteria, and the data requirements. Now, when you come to this point, just go back to this picture that we saw in our first lecture, okay? In the simulation lecture. So when we say scenario, we are talking about these things. It's the configuration of the system. Are we having single queue systems? Are we having parallel servers? Are we having servers in series? What kind of queue disciplines are you facing? Right? So all these things about operating policies come under the scenario. Is that clear? You understand what scenario means? So how the whole queues are set up is what you're trying to address here in scenarios. When it comes to decision criteria involves, what is your basis for decision? When you say something is the system is going fine or not, you have to pick up certain measures. Like, are you considering waiting times as the key criteria to judge your results, or are you like keeping the number of customers in the queue as the main criteria? Or maybe else you want system utilization. I'm sure all these terms are familiar to you now, right? From the last class. System utilization was that rho, right? Lambda over mu. So that might be of your concern, right? You want system, if the system is not busy 80% of the time, you think that it's not good enough, right? So and now to select the right one, you need to look at your problem statement. You need to understand the context. For example, if you're concerned with a hospital system utilization, do you think it is of a primary concern to you, or the waiting time is more of a concern to you? Yeah, that's how you pick. But if you're talking about an industrial system where you're dealing with a very expensive hardware, so are you concerned with waiting time, or are you concerned with system utilization? So that's how you have to pick, the right measures. It depends on the context of the problem. Now the question is, do I have to pick one criteria, or I can pick more than one? Manat, is there a problem? I hear some discussions going on. Are you all okay? Okay, I heard a no. Oh, I thought I heard a no. So, okay, anyways, so you understand what we are saying, right? Let me check. I have started recording. Yes. Okay, so where were we? Yeah, the decision criteria. So my question is, do you have to pick one criteria only? you can always pick multiple, depending, but it depends on the situation, right? So once you selected your problem, you have to go through all these things. So let's just now connect this back to your project. So once you pick a problem, you can talk to me, informally, but then you have to come up with a problem statement. Or if you feel that it's already a good problem, better to come up with at least like an initial level problem statement so that I can read and I can understand what is going on. Okay. So maybe in the next class, one of the things we can target is you select a problem and write a problem statement on it. Okay. So that, and then you need to be keeping these things in mind: scenario and the decision criteria you have in mind. This part about data requirements can come later. Some of the things are obvious, of course, number of servers, but inter-arrival time, service time distribution, we can talk about it later, at a later stage in our project. Okay, is that good enough? So what is the first thing we have to do in our project, or in any simulation study for that matter? We have to define the problem, and we have to write a problem statement that clearly tells what is tell us what is going on, and where you are facing the problem. And then what is the next step? Yeah, the objectives, right? Now, one of the things that we did not discuss was the questions, right? I think we already discussed that earlier. The questions are of only two types: what and how, right? How is already obvious to us. We are doing simulation study, right? So that is not a problem. So the real question is, what are we trying to address? Now, the first one is always going to be there with us. What measures of performance, what are we trying to measure, or how we are trying to estimate the performance? Now, can you link this to our discussion on the previous slide with something? How can we measure performance? The criteria, exactly. So the question, you need to link it up with your criteria, decision criteria, and your question. That's why I brought the question after our discussion on decision criteria. Okay. So what are we trying to measure? What kind of performance are we trying to look at and evaluate? Okay. And then, of course, just based on your visual assessment, you can see that certain operation is not going according to how it should be run. So you can identify, that apparently there are long queues, apparently there are long waiting times. We'd like to evaluate the performance based on that criteria, and after evaluation, we'd like to improve it by redesigning the system. Okay. So, sorry? What to improve again goes back to your criteria, right? So if you say waiting time is problematic, so that's first you'll try to precisely estimate what is going on at the moment, because I went to the hospital or someplace, and I saw that apparently there are long waiting times. Now, when I say long waiting times, I'm just saying long waiting time, but how much is my waiting time? So I'm going to first estimate the performance, right? You understand that? And then after estimating the performance, I say I want you to improve. Improve what? Again, it goes back to your decision criteria. So it connects everything together. So you'll say, I want you to improve the waiting times, right? So whatever measure that you have selected, so you have to be careful about it, because then it will drive everything. So if you say utilization is not enough, it means that first you have to estimate the performance, exactly whatever is going on, okay? And then based on that, you say, I want you to improve what? When I say utilization is my problem, so you wanted to improve what? That's how easy it is, right? many a times the criteria are correlated, like the number of people in the queue and the waiting times. You can imagine that the more the number of people, the more the waiting time, right? But if the criteria are opposite to each other, like utilization and waiting times, right? So as a business, you have to make a call. You remember about trade-offs? You know, we had discussions maybe somewhere in even if in not in this course, in HCI or something, right? Where you have conflicting objectives and you wanted to consider both, then you need to decide which one is important to what level, right? So you wanted to improve utilization, but not at the cost of compromising too much on waiting times, right? So eventually, you know, your whatever decision criteria you set up will drive, you know, your evaluation and your objectives for improvement. Okay, not a very complicated thing. It's common sense, right? So I need to know what my problem is. I need to define my problem, its scenario. I need to select my decision criteria, and then I need to set up my question, which is nothing but an alternative representation of my decision criteria, right? So if I say waiting time is my decision criteria, then my question is naturally, what is, you know, how am I doing on waiting times? And then my second question is, if the waiting times are high, which most likely will be, because that's why I'm conducting this simulation study. You know, the question is, how can I improve those waiting times, right? The exact waiting times that I can I've obtained during performance evaluation. Okay, now here is where we are now going to go deeper into the finer details, but we are still into problem definition. We are jumping between problem formulation and the objectives, okay? So they are kind of linked. Problem formulation, first we discuss at a higher level. So it's just a statement saying that there's a problem. You know, this is what is going on. This is the company, you know, this is how they work, and, you know, based on their business, they're facing these problems. And then we set up our scenario and objective. Now, the same scenario, the same objective, and the same problem somehow needs to be formalized. Formalized means something that does not solely depend on understanding of words. Like in HCI, you wrote something, but then you came up with a conceptual model, right? Something that is more easily understood by people, the team, the clients, the, you know, yourself, right? So we need to develop what is called a conceptual model. So the whole thing that we discussed earlier, you need to translate it to a conceptual model. When we say model, we are trying to clearly identify the difference between reality and the part we are trying to capture in whatever way we want. So there's always a difference between how we are perceiving whatever is going on and to what extent, and, you know, whatever is going on. So imagine, you know, the example of hospital. There are too many things going on, but are we capturing the whole hospital? Even within the ER, we are isolating ourselves to reception. We are making a decision, right? We are trying to create boundaries. So we are keeping few things away and trying to include certain things. So and it goes back to, you know, what is your question, what is your problem you're trying to address, right? So because you have already written your problem statement and you have defined your you know, your questions, your decision criteria, it will be easier for you to draw that boundary. So you'll be making assumptions that this is not related to my problem, so you throw it out, right? For example, you know, in a grocery store, I'll say my problem only occurs in the evening, right? So even the boundaries could be on time. I say my concern is from between Maghrib and Isha prayers, right? So maybe that's like where the majority of the people go to groceries. Or I'm saying that the problem is only during the weekend. I'm trying to address the problem of these queue buildups during the weekend, right? Do you see how am I maneuvering through this concept, right? So I have a real system, but I'm trying to isolate the portion which I would like to address and solve. Okay. Now, so based on the real world, I have a concept in my head, which is the assumed system. So I would like to somehow convert it on paper so that others can see and read and understand, right? I might be trying to convey that this is the problem I'm trying to solve, but somebody else might be solving it, right? Somebody else might be doing the simulation, right? So, and even then a client came to me with the description, and then we need to make sure that we are thinking about exactly the same problem. So the conceptual model can be looked at by both the client and yourself and your team. And then if everybody agrees, then this is the problem you're trying to solve. So conceptual model has multiple purposes, right? And then there's something called a logical model. So what is logical model? Conceptual model is nothing but, a model that you have created on paper to define the boundaries of what is inside your problem and not, right? Now, this conceptual model has to be translated to arena. Previously, when there was no arena, people used to write Simon codes. Do you remember I talked about Simon programming language? So simulation a few years back, 15 years back, even 20 years back, this visual programming was not there. Even if you're writing code in C or Java or whatever, or in Simon, let's say, you still have to convert the conceptual model into a programming model, like flowcharts and whatever, right? You remember there were flowcharts like logical if and loops and all those things. So you convert that logic concept into a logic. Now this has become less important, honestly, because the programming logic is very easy to handle even at that level. That the conceptual model can be translated in almost the same form in arena. So the loops and all those things are less important to us as the people who are doing simulation, right? But you still need to know that there's something called a logical model. Now, what I will show you, inshallah, later when you'll be writing your drawing your arena model. There's a place where you click, you'll actually see a Simon code being written in the background. You can even directly edit that Simon code if you like to play with Simon programming language, right? So despite the fact that the visual programming is there, the visual programming only helps you or write the code automatically. So when you drag and drop an arrival, actually in the background, there's a Simon code being generated by Arena. And that is actually the code run by the simulation engine, not the Arena visual things that you're looking at. So visual code, visual effects that you see is just like a layer on top, okay? Close to that, but like in Orange, you remember Orange? We used Orange few weeks back. It's actually Python behind. So once you drag and drop and the model you have created, you can ask Orange to actually show you the Python code written, right? So that's what I'm saying. So if you know how to write Python, you have that code in front of you, which you can edit by yourself even. If you're like really power user. So you know Python, you know Orange, you know everything. So you can go back and edit the code by yourself to customize it even further. So just like this, here you can do that. So logical model for us is not the most crucial one, but you know the role for it. And then, of course, you need to be discussing it with the people who work there in real situation, maybe not in your project. But if your company is facing a problem, you need to be talking to your managers. They can explain exactly what is bothering them, in terms of like this is not going right for the business, right? So from problem definition to the conceptual model, all these people must be communicating with each other. You can see the loop. Loop always means they keep on talking and they keep on refining the understanding. Now, conceptual model, you can use any tool you like. This the images are meaningless here. The idea is you can use flowcharts, you can use the tools that you have learned in system analysis and design, the ER diagrams and whatever. It's entirely up to you, what tool you would like to use, as long as the tool is serving you to explain, the problem. Okay, so it might be an input process output. It might be like a process flow diagram, and so these are just examples. So you are kind of free to do that. Now let's go into even more details. I said that so far. I said that to define the problem, you have to write a statement, right? Then I said you have to define few things like criteria, the question, and the scenario. And then I said, no, that's not enough. You have to develop a conceptual model. Now I'm going to tell you that you need few things in the conceptual model that are a must, M-U-S-T, must, for a simulation model to work. If you're not defining those, then you are missing some very important elements to your conceptual model. So what are those? You must define what are the important events happening into your system. Okay, and each one, inshallah, I'll be defining them one by one separately. So you must be defining what are the activities going on in the boundary that you have drawn. Right, so I told you that in the assumed system you have drawn boundary. So you should not be including every activity going on there, right? A security guard standing there and says that's an activity, but not of our interest, right? Even in there was someone who asked me, I think from this side. So if you're doing groceries, are we like looking at customers entering into the grocery store, right? Someone asked from there last time. Now where is queue building up? I'm trying to now open up your mind and try to let you show how you have to create those boundaries. So I'll go back to this question. I don't know who asked that, but is this where the queue building up? Where is my queue building up? And I suppose you're saying cash counters, right? So do you think that people entering the grocery store at that point that is of our interest? So where is the point of our interest? When someone is joining the cash counter in a queue, this is where our problem, this is where I would like to draw my boundary. So when you're going and thinking about problems, you need to be thinking like this, wherever there are queues and services happening, I need to be isolating that part. And then I'll be talking about in that boundary, what are my events, related events, what activities are going on within that boundary, or what are the entities. So entities means like customers, for example. When the customer is entering, the store, is that entity of interest to me? Certainly not. The customer can enter and move around for as long as he or she likes and leave without even buying anything, right? The customer is of interest to me for my queuing system when that customer joins the queue, right? So then there's something called attributes. We need to learn about all these, inshallah, one by one on the next few slides. So I need to know what are my resources. So that security guard standing on my grocery store entrance, do you think that resource is of any interest to me? Again, you have to make sure that you are looking at your boundary and what is relevant to you. Variables, we'll see what variable means and their relationship. Performance measures we already talked about, right? Data requirements we'll inshallah talk about. We have to define what data we have to collect. So you'll be developing partial conceptual model, and then We'll move on to this inshallah in some next class. Select correct level of details. Now this is going to be a very tricky part. Sometimes, you know, the things that you are deciding to add or not to add are very clear. Like the example I gave you about security guard, right? But there are certain details which are which have like you're not sure. They are maybe relevant but not that relevant. They may be affecting the way you're developing your conceptual models, right? So if I have I don't know how to give an example here, but you know, the time unit that I'm selecting for my study, right? So if the smaller the unit, how do you think you'll be becoming more precise or less precise? More precise, right? But you know, so should I go for nanoseconds or what? Because I'm saying the smaller the unit, the more precise I become, right? So I have to make a call. What is the reasonable level of details I would like to live with, right? So these are like, you know, some of the decisions, trickier decisions I have to make. So let's just, I think I'm hoping that you have already installed Arena by now. If you have not, please go and download, because I'll be asking you to bring you know, the computer anytime, okay? So let's just go and talk about each one of them, each of the terms that I mentioned. So if in your report I don't see explicitly where you say entities and this is my entity of interest, entity or entities of interest, it means that I can have multiple kind of each, right? So entity, if I don't see one, there's a problem, okay? So we are going in a very structured way, and each one, all you have to do is to one by one, you have to address and add. So what is an entity? Entity is an object of interest in the system. Dynamic objects that gets created, move around, change status, affect or get affected by other entities and leave the system. In simple terms, these are your customers who wants to get service. These are called customers. These are called entities. In a healthcare center, patients, visitors, these are entities. Remember, human is not an entity, because human can be a patient, or as you'll see on the next slide, a human can be a doctor or a nurse, which would become what you call a resource on next slide, right? So you have to be precise about it. Now, here I would like to throw more clarity into your mind when we say not entity, entities. When you say patients, is this sufficient when it comes to healthcare? Or let's think of an ER. When patient comes, what kind of patients come to ER? Yeah, in ER like emergency room in hospitals, you see a couple of different kinds. Do you see that when they check, you go to ER, the nurse takes certain data. What is she trying to do there? She or he? She's trying to identify your level of, the level of criticality. They say there's a box, if you notice, they say like not an urgent issue, and they say go please sit there, and that's where you suffer. And but God forbid, if there's something like a serious emergency, they say immediately take in. And then there are even patients, they don't even wait to fill the form. It comes, God forbid, in ambulances, they they even call before everybody is ready, even before coming, right? So it means that we have types of entities. Serious patients, less serious patients, non-critical patients, and you'll find their description that they are using in the hospital. Just like this, if you're talking about groceries, there are people who are coming with, let's say, this is where it becomes tricky, and we have to discuss. There are customers with less than 10 items, right? Small trolley. Of course, they cannot be compared with a trolley that is overflowing, right? So somehow we have to distinguish between customers with a lot of stuff and custom, right? Yeah, so if you're going there, you don't only look at the length of the queue, right? You see, oh, you go there and you see one person standing with 500 items in the cart, and you see two people standing there with one item in hand. What do you do? Yeah, so it means that you're distinguishing between two different kinds of customers, implicitly in your head, not explicitly, right? Yeah. So based on their attributes, you can, you know, in SQL, you talk about attributes, right? It is, we are going in the same way. Conceptually, it is the same thing, right? So for each entity, there are attributes, and based on attributes, we are classifying the entities, right? So you understand what, how do you deal with your entity. So next time, now, are we expanding on our problem statements? So it's not just that I'm having a big queue problem, right? Now we are going more precise. We are talking about, you know, we are having somehow informally, this should reflect in your problem statement that patients come of different categories or customers of different categories, and then, you know, they go and seek so and so resources, and you know, so your problem statement become more like substantive. Okay, then we have something called an attribute, like just you mentioned. So what is an attribute? Attribute is a characteristics of a particular characteristics of entities, but with a specific value local to the entity that can differ from one entity to another. Why are we being so precise? Because isn't it like we're simply saying that each entity has an attribute, right? We are saying this, but as you'll see on the next slide, there are some attributes for those entities, and then there are some attributes for the bigger system itself. So we'd like to separate that by using two different names. So when we say attributes, we are specifically pointing to the entity that we just defined having so and so characteristics. Okay. Now again, this is where you have to make a call. If a customer is entering into a market, you have to know what attributes are relevant to you. Do you think height would be of any value to a grocery store? No, right? But maybe, you know, if you think of clothing stores, the gender has an impact, right? If a lady enters, you say, please go there, you know, you'll to the ladies section, right? You'll guide them to the ladies section. If you see children coming in, then you say, this is where you find children clothes, right? So those attributes, you need to know what attributes are important to you. So for example, in terms of patient, type of illness, age, gender, temperature, blood pressure, so these could be like the attributes, but this is like specific to the entity you're talking about. I'm not using my pen, but I don't think we'll be needing pen, right? So I'm not writing anything on the board. So anyways, so resources. What are resources? Resources are anything. The service provider, you can use the word service provider, but service provider is the company. The actual resource, you have put me into an odd position. The resources are actually that provides the service. So by definition, it's a resource provider, service provider. So is the grocery store the service provider in your mind, or the cashier? Yeah, so we are talking about those things. Okay. So resources are what entities compete for. So entities, they enter the system for what? In simulation language, they are there to what you call seize a resource. It's a term that's used by all simulation people. You will always hear, you know, an entity seizing a resource. That's a term used. Seizing means, you know, capturing the resource to get the service. Okay. So when you're standing on a cash counter and you're waiting for the cashier to look at you, so immediately as the cashier says, please come, now you have seized the resource. And when once done, you pay the amount, then you have what you call released the resource. So we may have a situation where you have something called seize, delay, release. Seize means you capture the resource, delay means you get the service, and release means you let that go. Now there are resources which just requires delay and release, like a room. You don't have to, by multiple entities can enter and leave. No, so when you're seizing, that's like you have a dedicated service for yourself, like a cashier, right? But if the resource is a room, you may have another kind of a resource which does not require seizing. So, but normally we are talking about seizing a resource and then using it and then releasing it. Think of a resource being assigned to an entity rather than an entity belonging to a resource. So a resource can of course have multiple units. So if you're saying a doctor is a resource, so of course you can have multiple doctors, multiple nurses, but it does not have to be people. It can be a server, right? Like the ATM machine, or a web server, or a database server, or a computer processor. Like when you're running multiple, you remember in Python, we talked about parallel processing and so on. Different even applications running at the same time. So there is even a queue. The queue is so fast, it's running in nanoseconds and faster. So you don't observe until it is put under severe pressure. So if in that case, even the queue is building up. There are waiting times for a program to get a chance by the CPU to do the processing and so on. So anyway, so you know what a resource is. So I need to have a clear section talking about that these are resources relevant to us. So once you write resources, we need to have a discussion whether these resources are relevant, right? And then we'll also discuss if something important is missing. So each component, inshallah, will be each of your group will be discussing part by part, piece by piece. Okay. So entities, you say, I feel that these are the entities relevant to my system, right? And then inshallah, what we'll do is we'll see if those entities make sense. If they don't, we'll revise our definition, right? If there's anything redundant, we'll try to take it out. So so we have talked about resources. What next? Variable. You remember I just mentioned that there's an attribute for an entity and there's an attribute for a system. The whole system. So because we do not want to get confused between an attribute for an entity and an attribute for a system, so we use the term variable, which is for the whole system. Okay, so when we say attribute, we are specifically talking about the entity. But when we say variable, we are talking about the whole process. So a piece of information that reflects some characteristic, again characteristic, an attribute of the whole system, not of specific entities. So for example, number of patients in the system. Is this a characteristic of the whole system or a particular entity? It's the whole system, right? So right now I have 5 patients in my system. I'm now talking about the whole system. So I'm saying that the number of idle doctors. So I'm talking about the whole system, not about a specific one, right? The current time clock, if that is required. So entities can access or change some variables. It does not mean that entities have no relationship with these variables, or resources do not have any relation. They do, but these variables represent the whole system. So if my current number of patients are 5, an entity enters my system, so what will happen to my number of patients in the system? It will increase, right? But still it will be a characteristic of the whole system. So is that clear? So we needed to know about what variables are you keeping in your study. State. Now state of a system is if you have multiple variables in your system, together they define a state. How many patients do I have in my system now? How many doctors are idle? How many doctors are working? Together, the whole picture the whole big picture. Snapshot, if something is going on and I take a picture, that's like what you call a state. Now I'll take you back to the name of this simulation that we are doing. What was the name of this simulation? We gave it a name. No, we said that there are different kinds of simulation. Monte Carlo simulation, yeah? Monte Carlo simulation, continuous simulation, discrete event simulation. So, discrete event simulation, right? Discrete event. So, it has to do with this concept of state. State remains the same until an event happens and the state changes. That's how we define the discrete event simulation, right? You remember, if you remember our discussion back then, we said that unlike continuous simulation, like in dams, where there's a continuous change, water flowing in, going up, going down, in discrete event systems, the system stays stable, which means that its state stays stable until an event happens. So I need to define now an event as well. But something happens that changes the state, which means that even if one variable changes, my state has changed. So if there are 10 people standing in a queue, next second, it is still the same situation. So has my state changed? There's no state change. Again, after a minute passes and still there are 10 customers and there's like a stubborn customer arguing with the cashier. So has my state changed? And then the customer leaves. Do you think my state changed? State of the system changed? I said a customer left. A variable changed. Do you think number of customers in the system changed? So this is state changed. Or a customer joined. So do you think the number of customers in the system changed? So the state changed. You understand what state means? So any variable value, if it changes, the state of the system changes. A collection of variables that contains all the information necessary to describe the system at any instant or instance of time. That's why I said take a picture. Instance means like exactly now what is going on here. So so together, all these things together, number of patients plus number of status of doctors, busy or idle, number of, so even if the number of customers don't change, but a doctor becomes busy, that's a state change, okay? And the status of lab equipment, equipment broke down or something, so that's a state change. Event, an instantaneous occurrence that changes the state of the system. Something happens that changes the state of the system. So that's called an event. A new patient arrived, state change. A failure of a medical equipment, a state has changed. Completion of a service, so a state change. So it's like you go to an airport, it's like a series of queues, right? You go from luggage to passport, right? So the number of customers are the same, but the state changed. The queue here is reduced by 1 and the queue here is increased by 1, right? So the state has changed. And because of what? Because of an event. Activity. Now, the good thing about simulation is that when you're taking the service, the actual service dynamics is not important to us. Which means what? If I go to a cashier, the cashier is pressing the button or scanning or typing, it does not matter to me. What matters to me, I'll just call it an activity. Activity represents a time period of specific length. It's a very generic definition, right? So activity means I went to a cashier. So for you as people who are doing simulation and study, it doesn't matter if the person is scanning or typing and taking cash or doing credit card or cash or ATM card or whatever. What would matter to you is only the time that is spent by the resource to give the service, and that is called an activity. So if a patient goes to a doctor, it does not matter what doctor is doing in there. Like doing the stethoscopes and checks and whatever. What matters is when a patient enters the room of a doctor, and when that patient leaves the doctor. So ceases, delay in which you're doing there is an activity going on, and then the patient leaves. You all understand activity means. So you should not be bothered about the actual work going on. Later, when we'd like to improve the service, what we want is maybe one of the ways to improve is to reduce service times. Now, this is where you'll talk to domain experts and go inside, tell me if whatever the way the service is given, can that be improved, right? So then you look into that. And then the domain expert can tell you, everyone is doing something not in the right way. If you do that, we'll be able to save 10% of the time on average. Then you say, okay, service typically, the average mean service time, the mu, 1 over mu, the one we learned last time. The average time was like 2 minutes. And by improving and redoing the way they are handling something, the average time reduces to like 1.5 minutes. Then this is where you have to go inside the activity, right? So we'll inshallah be able to look at those things later. But for activity now is just a period of time. As I mentioned, logical flow chart is not of a big concern to us. So, but this is just to show you that an event happened and the queue increases and the queue, and then the number of entities in the server and all those, how in my program all those numbers have to be increased or decreased. Think of it now as a Python programmer, right? So if I say I'll use a random number generator to introduce a customer arrival. So randomly it says a new customer. Now when that customer arrives, I have to update my variables, like number of people in the queue. So there's I define a variable called queue, which depends on whenever an arrival comes, it goes +1. Whenever there's a departure, it becomes -1. And and the -1 depends on again a random number distribution about service and so on. So now you're thinking now as a programmer, right? So, but the good part is we don't have to worry about it, because we have Elena. And Elena takes care of all these logical flows of Simon writing and everything, which is a good part, right? Very good part. Okay. Now I'm going to stop here. That's why I re-brought this. We have enough. So we need to make a line here. If we reach this part, then we'll move to the next stage for your projects. You all understand that? We have sufficient data at our hand. There is no point identifying what data to collect because we even don't know what our entities are and what our resources are and what activities are going on. So based on your conceptual model, so we have stopped here. This is the part we have covered. So how much time do you think you need? Although there's a timeline written on your project description that I gave you, but I think by the end of next Wednesday we should have this ready. So by Monday I want to have something in front of me that I can give feedback to you, okay, and that I can tell you that this is missing, this is available, this is not correct. You have to think about that, right? Even if not Wednesday, maximum by Tuesday, this should be finalized. We need to keep it, we need to move on from there because we have to, the part that you are excited about, the tech collection. Yeah. Last time I saw that you are all excited about collecting data. So I'll make sure because you're excited, you spend a lot of time there, okay? So is that good, Panath? You're all clear about what to do? As much as we can, okay? what I'll do is, last time we had a very good experience of these WhatsApp groups, right? It was very productive. So I'll try to create, those groups. In fact, I can send you a message, create a group by that name. So I need a consistent name. Like in Python, we had like programming 131.326-1 or something, whatever. And then you create your groups and include me into it and start discussing the problems there. And I'll try my best to respond if that problem is good enough. Okay, that will accelerate, the process, and hopefully it will save your time. Okay, so I'll just send you. Is Dima here today? Not here today. Yeah. Okay, I think I'll just talk to her. I hope she's okay. So I think she's still communicating with me through WhatsApp. So I'll just give her the details, and then we'll move on from there. Okay. Now, is there any other question you would like to ask? This is actually the purpose of this, to give you this flow of work. You have to think of your problem, write it down, at least what my problem is. Okay, because this will kind of allows you to create those boundaries. What is part of my problem, and then you go through. You remember the decision criteria, the scenario, and everything, and then you try to conceptualize. Conceptualize means you not only draw the flow chart. After that, you have to define entities, resources. So you go in the same way. Okay, is that clear? Lines don't matter. What matters is it are you able to explain that thing or not? You can have like a Layla Majnun story where that does not tell anything about the system, right? And yet you have like a paragraph explaining everything out of it, right? So the number of pages don't matter here at all. Okay, what matters is how precise and clear you are. Okay, so we'll stick to the clarity and preciseness and the quality of your results, the complexity of your problem, and rather than the number of pages. Okay. Shall we stop? Can we stop now? Okay. Thank you. And thank you. I still feel embarrassed taking. Imagine me going out with this after the class. This is what was I doing there? No, sorry. Something if I can hide this, it will save me with embarrassment actually.